Dalton's Law of Partial Pressures. B period. Project by Sydney Daniels, Megan Barabee, and Christopher Chow.
Hi, I'm Sydney Daniels, and I will be teaching about the terms and equations associated with Dalton's law of partial pressure. Dalton's law of partial pressure says that in a mixture of gases, the total pressure is the sum of the partial pressures of the gases. Dalton backed this law up by saying that each gas exerts its own amount of pressure, regardless of the pressures of the other gases. This law can be made into this equation, P standing for pressure. So the total pressure equals the pressure of one gas plus the pressure of a second gas plus the pressure of a third gas plus the pressure of a fourth gas, etc. This can be seen using the diagram taken from the textbook. We see that a tank of heliox contains helium and oxygen. The pressure of the oxygen is 100. The pressure of the helium is 400, so in total, the pressure of the heliox is 500.
My name is Megan Barabee, and I'm going to show you a practice problem using Dalton's law of partial pressures. This problem is asking what the partial pressure of oxygen is at 101.30 kilopascals of total pressure if the partial pressures of nitrogen, carbon dioxide, and other gases are 79.10 kilopascals, 0.040 kilopascals, and 0.94 kilopascals respectively. The first step would be to list the knowns and unknowns of this problem. We know the pressure of nitrogen, carbon dioxide, and the others, and we know the total pressure, which is 101.30 kilopascals. What the unknown for this problem is the pressure of oxygen, which is what we're trying to find. The second step is to solve for the unknown. First, write the equation for Dalton's law of partial pressures, then isolate what you're trying to find, or the pressure of oxygen, and then fill in the numbers for each of the variables, and you come out with 21.22 kilopascals for the pressure of oxygen. And for the last step, you make sure that your answer makes sense within the problem. This is how you use Dalton's law of partial pressures to solve a problem.
Hi, I'm Christopher Chow, and I'll be giving a demo of Dalton's Law of Partial Pressures. Here I have an ordinary balloon, and when I exhale to fill the balloon, I'll be filling it with more than just one gas. When humans exhale, they let out mostly carbon dioxide, nitrogen, and a little bit of oxygen. Each of the gases that I exhale in order to fill the balloon have their own pressures inside of it, and the total pressure of the balloon is the sum of all of the pressures added together. Summary. Dalton's law of partial pressures states that the pressure of gases inside a container is the pressure of each individual gas added together. When multiple gases are inside of a container, each gas has its own pressure, and when those are added together, the sum is the total pressure. An example is when a human exhales to fill a balloon. When a human exhales, they exhale different gases that go into the balloon. Each gas exerts its own pressure inside of the balloon, and the total pressure of the balloon is the sum of the pressure of each individual gas added together.